Hello, people watching this video. This is take 2. We'll see if it works. 3, 2. In 3, 1, we talked about vertex, which is this dot right here. The axis of symmetry was this line right here. The y-intercept was where he crosses like there. Today, we're doing this. We're still looking at quadratic functions, but we are looking more specifically at what's called the roots. Another name for a root is called a zero. Another name for a zero is called a solution, and all three of those things mean the x-intercepts. They are all x-intercepts. So if they call them roots or solutions or zeros, all their meaning is the x-intercepts. That is all. Okay? All right, standard form of an equation is still ax squared plus bx plus c, so you're still getting a, b, c from there. We're still going to find vertex in some of these problems, but we're looking more specifically at locating where he crosses, okay, here and here. So for this function, our zeros are at where?
3 and negative 2.
3 and negative 2. So we're going to say negative 2, 0, and 3, comma, 0. Those are my zeros. Those are where he crosses, right? Those two places, okay? So some of them on your homework assignment is just going to be identifying where does he cross, okay? And then some of them might say, okay, you have to find the places where he crosses and actually graph the thing. So that's what we're going to do in example 1. Here we go. They're wanting us to first find the vertex, okay? So I'm going to write off to the side over here. Vertex is negative b over 2a. If you don't have that embedded in your brain, get it, okay? Then we plug that number in to find the y-coordinate, right? All stuff we did yesterday, all right? So if that's the case, negative b, what is negative b? It'll be like negative 3, right? Which will make it a positive 3, so it just switches the sign. Over 2 times a, what is a? 1. Toby, crazy boy. 3 divided by 2 times 1. 3 over 2 is 1.5 as a decimal. 1.5 as a decimal. All right, now I find this guy by plugging him in, right? So I take 1.5 and I square it. Minus 3 times 1.5 minus 4. If you have a calculator, get it out, help us out here. 1.5 squared is 2.25. Let's see if I can do it in my head. 2.25 minus 3 times 1.5 is negative 4.5 minus 4. This is negative 8.5, and if I subtract that? Negative 6.25. Boom. Got it. Perfect. Great. Okay, now notice that they put that vertex center stage of our table right here, which usually is the way that it works. Center stage of our table, 1.5 comma negative 6.25. And then they want us to complete the table. We're gonna go ahead and do the table thing, and we're going to plug these numbers in, all right? We're plugging them into the equation again up here to try to figure out what their values are. So negative 1. If I take negative 1 and I square it, that becomes?
1.
Positive 1, right? If I take negative 3 times negative 1, that's plus 3 minus 4. What's 1 plus 3 minus 4? 0. So this guy's at 0. Okay? Good? All right. You don't have to write this work down. I'll write the work down. You just help me solve it, okay? So I'm erasing things. All right. 0. If I plug 0 in, 0 squared minus 3 times 0. This goes away. This goes away. Minus 4 is all that's left. So minus 4, yeah? All right. Next, I'm going to plug in 1. 1 squared is 1. Minus 3 times 1 is 3 minus 4. 1 minus 3 minus 4.
Minus 6.
Negative 6, I believe. Yeah. Minus 6. Okay, now, I could keep going, and I could plug 2 and 3 in. But if this is my vertex, it should be the same on the other side, right? So what's 2 going to be at? Negative 6. 3 is going to be at? Negative 4, and 4 is at 0, like they did, right? So we can kind of cheat some of these steps, right, if we know that he's going back the other direction, so we don't have to plug in as many things. All right, we are going to graph him. All right, negative 1 is at 0. Then we're at negative 4, negative 6, 6.25, something of this nature. Okay, then I'm going to list my zeros or my solutions. That's all we're doing. It says find the solutions by graphing. Where are my zeros? What are the coordinates of my zeros? negative 1, comma 0, and this dot is at 4, comma 0. Okay, now I can see that from the table, right? But I didn't even have to graph that. I can see that negative 1, comma 0 is an x-intercept, and 4, comma 0 is an x-intercept. Wherever it has a y-coordinate of 0 is going to be an x-intercept. Yeah? So I can see that from the table without actually even having to graph. We're going to talk about that later. Okay? Good? Was that too fast? Was that okay? All right, now, do we always have 2 zeros? Maybe we've talked about this before. Do we always have 2 zeros? 2 places he crosses? You could have 1 or none is what Ethan says. So here is a scenario of where you have two zeros, where he's touching twice, right? In this scenario, we have one solution. And this happens when this dot, which is called the vertex, is also the same as your 0. If your vertex is on the x-axis, that means you're only going to have one solution, right? He's going to touch that. So only one solution there. Now, you could have the scenario on the third graph where he's completely above and he's only going to continue to go up from there, so he's never going to touch this line, in which case we have no solutions, all right? Now, he could face down as well. If he goes like this, he's still not going to touch, right? So it's not that every graph has to face up, right? So if he faces down, that will still have no solutions. Can you have a quadratic function touch 3 places?
Yeah.
You can?
Quadratic.
Not quadratic. So Remington's like got this image in his head right here, right? Where I have this one, this one, this one. But is that a quadratic function? Is that a parabola? No. This is going to be an x to the 3rd power function. It has 3 places it crosses, right? Okay? So it cannot be a quadratic and have more than 2. So it either has none, 1, or 2 solutions where he crosses, okay? So we're going to see an example down here where I have only one real solution, okay? So we're going to plug these numbers in like they ask us to, and the first thing that we're going to do is get him ready to plug in, because look at that mess. Here's my equal sign. Oof. Yuck. I want to move everything onto one side, okay? Now, you can move it to either side, whichever side you want, but the beginning term is always going to be your x squared if you put them in order, right? So here's where my x squared is. If I leave the x squared on this side and I move this stuff over here, that x squared is going to be negative. What's going to happen if I move that x squared over to here instead? It'll be positive. You know which direction I want to move in? I want to always make that x squared positive if I can, okay? So I move this stuff like over here, all right? So the first thing I'm going to do is I'm going to add the x squared, okay? I'm going to add the x squared there, and I'm going to add the x squared there. So this is gone over here, right? Like we're moving stuff over like we've done in linear functions, all right? These 3 pieces, can I add x squared to 6x?
No.
Can I add x squared to 23? So what does that look like? Equals what?
Minus 6.
X squared minus 6x plus 23, right? Okay? And then I still have 14 over here. Now, some of you can add them both at the same time. Like if you want to move the 14 at the same time, by all means, go for it. But I'm going to subtract this 14 now. Which one of these do I want to subtract 14 from? The 23, because those are like terms, right? Okay? So if the 14 cancels, what's left over on this side? 0. Nothing's left, right? And I've got x squared minus 6x plus 9. X squared plus minus 6x plus 9. And now he's ready to go. Now let's plug stuff in, okay? So I have 1 there, number 1, and I'm going to plug 1 in. 1 squared. You don't have to write this down. I'll write the work down. You just help me solve it, okay? Make sure you write that down, but you don't have to write down plugging each one of them in, all right? So 1, if we plug 1 in, 1 squared is going to be 1. 6 times 1 is 6, so minus 6 plus 9. What's 1 minus 6 plus 9? 4. Okay, so 4 goes in that spot. All right, now let's plug 2 in. You can do some of this with a calculator if you want to. I don't care. So 2, if you plug 2 in, minus 6 times 2 plus 9. 2 squared is 4. 6 times 2 is 12. Negative 12 plus 9. 4 minus 12 plus 9. 1. 1, I believe. Okay, now let's plug 3 in. All right, 3 squared minus 6 times 3 plus 9. 3 squared is 9. 6 times 3 is 18. plus 9. 9 minus 18 plus 9.
1.
1, 0.
0, 0. Okay. Are we going too fast? Are you doing okay? 4 if I plug 4 in. 4 squared minus 6 times 4 plus 9. All right. 4 squared is 16. 6 times 4 is 24 plus 9. A lot of times what I do is I will add the positive numbers together. So 16 and 9 added together is 25 minus 24. 1, right? Okay. And the last one Toby says is 4. We can cheat, right? He's going back up. He's the same, right? So if we plot him, 1 is at 4. 2 is at 1. 3 is at 0. Then we're at 1. Then we're at 4. Or, yeah, 4. So this is what my parabola looks like. Notice that my vertex is on the x-axis, right? He looks like that. And I can see that from the table as well. Do you see that this is going to be your x or your 0? Because 0 is there, right? Okay. So listing out the 0. 3 comma 0 is my 0 or my root or my solution. That's a lot of zeros. 3 comma 0 is where he crosses, the x-intercept. Yeah? And there's only one of them because he is the vertex. Good? Happy with that? All right. Perfect. On the back side, we're going to skip 2 of these problems. We're going to do example 3 and example 4, and then we're going to skip the last 2 because we're just beating a dead horse at that point. Okay? Example 3. Example 3. Here we go. It says we're skipping 5 and 6. We're skipping 5 and 6. So cross them off. Okay? That's extremely satisfying to cross them off. Sure, go for it. Have some fun. There you go. All right, ready? Example 3. They give us like a story problem for this one. All right, so they say use a quadratic equation to find 2 real numbers with a sum of 15 and a product of 63. So here are my 2 numbers, and product means multiply. And that's 63. But if one number is x, I have to subtract that number from 15 to get the other one. Okay? If that didn't make any sense to you, ignore it. We're just going to use this to solve our equation. Okay? So, I don't think so. No. So, this is our equation, but I don't like the way it's looking now. I'm going to distribute this x through. So, what's x times 15? 15x. What's x times negative x? Negative x squared equals 63. Okay, now, we have to put some on one side. Are you going to move this stuff over here or move the 63?
The other stuff to make it positive.
I want the x squared to be positive, so I'm going to move this stuff on the left over to the right, okay? Now, can we do that all at one shot? Okay? 0 will be all that's left over here. If I move that x squared over, he will be positive x squared. I'm going to put him first, okay? Then what comes next?
Minus.
And it'll be minus 15x, yeah? Because that 15 will go over and it'll be minus 15. And then what? Plus 63. Do you see that? So you can add 2 of them over at the same time. Any questions about that? Does that make sense? How you can move those over? Okay, now he's ready to go. Okay, I'm going to not make a table. I'm going to find the vertex first. Let's do that. We can make a table. You can make a table if you want to, but I'm going to find the vertex. Okay? Vertex is negative b over 2a, comma, plug in. Plug in. Okay? All right. What an ugly negative b over 2a. Negative b. What will negative b be?
15.
Positive 15 over 2 times, what's a? 1. Okay? 15 over 2 times 1 is 15 divided by 2, which is 7.5. Ooh. If you plug 7.5 in, does anybody have it? I think it's like 6.75 or something. I can't remember. Yeah, it's gross. I think it's I don't remember. 6.25. 6.25. I think. There ain't no way.
6.75.
6.75. Gosh, I was wrong. 6.75. There we go. Okay, so there's my vertex. All right. Let's plot that vertex just real quick. Okay. I'm kind of trying to cheat here because I want to avoid making a table at all costs if I can, right? So 7.5. 1, 2, 3, 4, 5, 6, 7.5 is there. 6.75. 1, 2, 3, 4, 5, 6.75. There we go. This is my vertex, that little dot right there. Okay, now, From that dot, I know that he is going to go up. He's going to smile, right? Because he's positive x squared. Okay, so here we go. He looks like this. I don't know how wide or how skinny he is, but that's what he looks like. Which means the zeros, where does he cross?
Nowhere.
Nowhere. He has no zeros. I avoided making a table by finding the vertex. Go me. Beautiful. Love it. Okay, do you see how that works? He has to go up from there, so there's no way he's going to come back down and touch the x-axis. No way. All right? Last thing. Sometimes, so like here, if you look back at like what we did on the backside, right? Looking at this table, we can see that this is going to be a place where he crosses. This is a 0 at 3, right? Because he's touching 0. Up here on this table, my zeros were -1 and 4 because that's where 0 was, yeah? But sometimes you'll have a table. Take a look at this table that you have right below. This one doesn't have 0 anywhere here, right? There's no zeros as the y coordinate. Okay, but if I look at positive, negative, 3 and -6, 0's got to live in between 3 and -6. So that means I'm going to have a 0 between -2 and -1. And I will have another 0 or another place where he crosses that is between what? 0 and 1, right? Because 0 lives between these two numbers, okay? And between 0 and 1, yeah? Good? So sometimes he won't cross in a nice place. Sometimes he'll cross between two numbers, right? Okay? So he crosses between two numbers because 0 lives in between here, so this is where he's going to cross between. 0 lives between here, so this is where he's going to cross between. Okay, let's do an example of that, and then this is the last one. So we have this function, x squared minus 6x plus 4. He's not going to cross at a nice place. Let's find out where he crosses. If I plug 0 in, 0 squared minus 6 times 0 plus 4 is 4. Okay, let's plug 1 in. 1 squared is 1, minus 6 times 1 is 6, plus 4 is -1. Okay, now if I plug 2 in, 2 squared is 4, minus 6 times 2 is 12, plus 4. 4 minus 12 plus 4. -4. 3, am I going too fast? Are we doing okay? Okay, 3, if I plug 3 in, 3 squared is 9, 6 times 3 is 18, plus 4. -5. Okay, 4, if I plug 4 in, 4 squared is 16. 6 times 4 is 24 plus 4. Sometimes I like to add my positive numbers together. 6 and 4 are positive. That's 20 minus 24. -4. I can stop. What's the next one going to be? -1. You see the pattern? We've started to repeat, right? And then the next one is 4. Okay, so without graphing this, I'm going to have zeros, because I don't have any zeros right here. Like there's no 0 y coordinates, right? But where are my zeros going to be located between? 0 and 1, because 0 lives here, right? Between 4 and -1. I have a 0 there, so he's going to be between 0 and 1. Do you see how that works? Yeah. And between 5 and 6, right? Okay, let's graph him and see if that's what happens. So 0 is at 4. 1 is at -1, 2 is at -4, 3 is at -5. I'll quit talking because it's really annoying. There we go. He doesn't cross nicely. Does he cross between 0 and 1? Does he cross between 5 and 6? You betcha. Those are where my zeros are located. So you would just literally say between 0 and 1 and between 5 and 6. That's like, this is how you would write your zeros out. Between 0 and 1 and between 5 and 6. Okay? Good? Okay. Okay. All right, on your homework assignment. Skills practice. Skills practice. I have weird instructions again. Skills practice. Do 1, 2, 3. Skills practice. Do 1, 2, 3. Okay, let's do 1 together, and I'll show you how easy this is. They're saying find the solutions. What's the solutions of number 1? The x-intercepts. What are the x-intercepts?
1 and -3.
1 and -3. I'm going to say 1, comma 0 and -3, comma 0. Those are my x-intercepts. Look at how easy that was. Then you go to the next one, right? Like those are super easy and fast. Okay, now the bottom ones, you're going to do 4, 6, and 8. And they say make the graph the thing. So I have put together some tables because I don't want you to waste time plugging in numbers that you don't need to plug in. So I have made some tables. So if you want to go ahead and copy my tables, these are numbers that are really nice to plug in that should give you an idea of what the graph looks like. Okay, so maybe copy those tables down and plug those numbers in. Okay, because those are the nice numbers that I want you to plug in. Then we'll go to the back stand and show you. So just 1, 2, 3, and 4, 6, 8 on this side. Actually, it's going to be the same on the other side. 1, 2, 3, and 4, 6, 8 on the other side. But I'll give you your tables here in a second.
Yay, no 9.
No 9. Yeah. It'll be 1, 2, 3, 4, 6, 8 on each side.
What are the sequence of the practice? Same?
1, 2, 3, 4, 6, 8. Did you get your tables written down? The numbers that I want you to plug in? This is skills practice still. Okay. On practice side, here is the numbers that you should plug in on practice side for 4, 6, 8. Okay, so use those numbers to plug in for 4, 6, 8 on practice side. Okay, use those numbers. What you doing, Cord?
Oh, we don't have to like calculate them.
You will. Did you write these tables down?
Oh, yeah.
Oh, go to this one. So 4, 6, 8.
Okay.
Make a table for those, and those numbers are what you should plug in.
And in a test, we have to use like 5 numbers.
Usually
Like
5
you
numbers.
can
I'll
do,
usually
you can
give
do
it
it
to you.
with a 4.
What?
You can do it with
You
a 4.
can do it with 4, but yeah. If you pick the right 4, right?
You can,
Like if your parabola is over here, but you pick the numbers over here,
no,
you're not gonna be able to see
not
them.
in the-
So that's why I gave you the numbers, so I know like these numbers will give you a graph of what it looks like. Yeah. So use those numbers. Use those
So for the
numbers.
practice,
I know.
this phrase is the same like this
Ultimate
one.
rebounder.
Yep. You're
That's
just
all we
writing
need
where
to
it's at.
pass. And blocking shots.
Yeah, HBC.
So make sure you get those numbers written down for the tables. What numbers to use to plug in. Okay. Did you get the other one? Do you want the other one? 0 through 5
Oh, yeah.
on this one.
He's 6'3". Simon's 6'7".
Oh, okay.
No.
Simon is 6'7".
You have to.
You're joking.
No.
Yeah, I was like,
Yes. Simon is 6'7".
Have you seen them?
No.
4 inches.
Is it like a, like? 1, 2, 3. That's not bad.
So for this, all we have to do is
Corbin,
graph.
how are you?
And then tell the zeros.
Oh,
And if it doesn't happen nicely, you say between here and
Yeah,
here.
remember this
Okay.
movie?
so if it
So
like
kind of the
doesn't,
same instructions as 1, 2, 3, except they don't give you the graph.
so if it doesn't graph nicely on like what do you
Never
say
mind.
it's
Great.
working on
I'm
that?
so glad.
Okay.
I don't even want to know what you were doing.
I was plugging calculator.
I don't know if I have one.
Does that make
Oh my
it
calculator.
Yeah, he make it better.
You,
He
oh,
definitely make
Yeah.
it better.
Yay.
Why do you like it so much?
because
Yeah.
you started
Why?
back here and
It's
there.
funny like
That's a little bit concerning.
no because I don't like
No, this one.
like I don't
Why?
saw it like
What?
It's kind of
if I just see this picture
But it
I
should
don't
be what
saw
you did.
why
Okay.
it's like if someone posts it
You
I
would
would
understand.
but he put the cherry on the top.
So what?
Are you guys done writing?
No, like cherry on the top.
No?
Yes, Jack.
It's the best.
Jackie?
It's funny.
Cherry in the top of the picture.
Only because this is like okay.
Okay.
But
Oh, I'm still recording. Bye, people on the video.